All right, guys, welcome to the next PCB workshop. This is session 6. Um, the first thing I'm going to talk about, let me go ahead and share my screen. We're going to go over the auto router, and we're going to talk about auto routing. It can be a very useful tool while you're designing PCBs because it can route the traces for you, but you should never, ever ever use it to do all your traces. That is highly unrecommended. Um, it can be good when you have like a specific track. Maybe it's not like an important signal. It's not power or ground. Then you can use the auto router and you can actually pick parts from your PCB design and you can select them and it'll auto route that single track rather than the whole board. And I'll show you guys how to do this, do that. One general rule, so I was going to tell to all of you guys, never route the ground tracks with the auto router. It's not worth it. Um, you can um, you can take your board and create a ground plane first for the for the back or front of your board, whatever you prefer, and then you can import that, and it'll have the ground plane. In which case, it might be okay to make the grounds, but still, I wouldn't recommend it. I recommend doing the grounds manually. Don't do any of your power traces through the auto router. Don't do any high frequency signals with the auto router or any antenna signals. Anything that's carrying something important, probably best to not auto route them. Okay. Everything else you can auto route and it'll do a decent job, but most auto routers are crap. And the reason is because auto routers don't know why this trace is important or why it needs to be a certain distance. Um, all it knows is this track needs to get from point A to point B, and it'll do just that. And that's it. Nothing else. So I highly recommend moving traces around after you've used the auto router, but it could be a useful tool for getting some quick normal connections, maybe like digital readout pins or some input pins that are like really low voltage or 3.3 volt connections. That is okay to use the auto router for. But if you're a really good professional PCB designer, you probably shouldn't use an auto router at all. So this is just a tool I used a lot throughout my design to make sure that my layout was okay. So basically, I would have the auto router do everything, and then I'd see, oh, this area has a lot of congestion, so I'll move these components elsewhere. And then I'd throw it back in the auto router, see how the traces look, and then I'd remove everything and reorganize all my components. So this link right here on GitHub is the auto router I use. It's called free routing, and then there's a Windows and a Linux version you can install. So go ahead and just go to that link and then install those. You're going to want the MSI file, or if you're on Linux, just install the zip and then run the executable. And then we probably won't get to using the auto router today, but I just want you guys to have that ahead of time because we only have 2 more sessions after this and then it's over. So I'll have these all recorded, of course, on YouTube so you can view them. And then once you guys are done installing that, just go ahead and open up KiCad and we're going to start the new project for the ESP32 developer kit. Okay. Yep. So I named it ESP32 dev. You can name it whatever you want. Again, I put it in my projects folder. And then I made another folder for it. So IEEE ESP32 dev kit. And then of course, the first thing we're gonna be making is the schematic. I'm not sure how to share this with you guys, but there's also a textbook I was referencing, but the PDF was too big to share on the My PNW Life webpage. So I'm trying to figure out another way to share that with you guys. Yeah, we could do a Google Drive link, but I could just show you where I download it. You think Discord will let you send a file that big? Or? Okay. Right, right. Yeah. Okay. I'll create a Google Drive link then, and I'll send it in the Discord. So just keep an eye out for that. All right, and then we're gonna start going through the same thing we did before. We're gonna start laying out the developer kit. In that book I mentioned, they reference a specific schematic for creating the developer kit. So you guys will be able to view that. You can probably find it online too if you Google ESP32 developer kit. One thing that I saw that they did that I kind of adopted the more I did more PCB design is they sectioned off their designs into these little boxes. So if you want to do that, I just use these graphic lines here. So you can click that and you can create these little square comment boxes over anything. It just helps you organize all your connections and stuff. You can also do the hierarchy sheets, but like I showed earlier, um, but I don't think it's necessary. I didn't want to like overcomplicate it. So I guess we'll start with the ESP32. This will probably take a little bit. So this is the ESP32. I don't know if you guys will already have one because I think I had to import this. You guys let me know when you add the component if you can find ESP32. It's going to be the ESP32 room 32D. Uh, under RF module, right? Yeah. Okay. All right. Yeah, that's the right one. So go ahead and place that. And then go ahead and add all your local connections. So in the schematic, they just named it after the same thing in the symbol. So here's my enable signal. Here's my sensor signals. SD 0, 1, 2, and 3, clock, command. You'll need all of these. So the developer kit is going to go to a bunch of pins so you can put it on a breadboard, which is this section down here. So even though you might not necessarily be using all these connections, they're all going to be available when we actually print out these dev kits and hand them out. Still looking for something to do with them, but I wanted to see like what anybody could come up with because I just wanted to focus on the PCB design aspect. Another really good thing, I'm not sure if I went over this in a previous session, but it'll be good to go over again. Um, when they listed their components and they put in the values, they didn't just put the value of the capacitor. They also put in the rating and how different that capacitance can be. Which can be useful if you actually want the components placed on the board when you go to order it. Because you'll see this value signal here or value tab. That value will pop up in your bill of materials. So you'll see 22 microfarad, 10-volt rating, with 20% tolerance. So when you're looking for your components, you're trying to find something online, it'll just be easier being able to see it there in the BOM rather than having to refer to a separate data sheet over and over. And then for the connectors, they're all going to be male connectors. You're going to have two of them. So there's 19 pins on each side. And that should already be included under connectors with the default KiCad libraries. So you're going to want 1x19 male. And then you can just place these over here. Remember that, I mean, it looks weird because these connectors aren't like attached to anything, but they're completely visual. It's just so that KiCad knows what connections it has to make to what. Each of these connectors are going to have footprints associated with them that will be the actual pins on the side of the board. So once you finish all those connections on the ESP32, we're going to move that over to the connectors as well. And then you can also create a little comment box for connectors. Oh, so power flag, go ahead and click P, and then all your power stuff will pop up, and then you can search power flag, or I think it's PWR. Yeah, PWR_flag. This is just so that KiCad understands where your power is coming from. You technically don't need it, but it's just so that the electrical rule checker would shut up. This one right here. So it's a 10K, 5%. Did you mean like the application of it or just the value? Okay. Mm-hmm. Yeah, so you can go to the right side here and it actually shows you the shortcut right next to it in the label. So add a symbols A, ground, or anything power related is P here. W for add a wire, and you can go down this whole list. They have a shortcut for everything, I think. Do you see that in this room? Yeah, okay. Yeah, you can also go to the help tab again too, and you can list all the hotkeys, and it'll show you every single hotkey, and then you can customize these as well if you'd like. Just let me know once you guys have all those connections, and we can move on to the other parts. I zoomed in a bit. So it's another nice thing with this basic symbol is it also already comes with a footprint, and you can find the data sheet here as well. So you can add extra information in here as you find more stuff about it. There's also, I think, you can add certain values that might be useful for when you start putting together the BOM, like with different names other than the value explaining what the component is. But I haven't messed around with that a whole lot, so I just know like something like some symbols like DigiKey, they add a whole lot of different information there. Uh, this is the place to do it if there's a website link or anything, PDFs even. I can actually click on this button right here, and this will take me straight to the one of the data sheets. Yeah, yeah. Yep. So we just wrapped up one of our previous design. I can show it to you after if you like, but I actually simulated that one on LT Spice so you can make sure the LEDs are gonna light up and stuff. So sure. I'm not sure why this one's rated 50 volts. That was in the schematic. So yeah. Yep. I have VDD 30. So that's 3.3 volts right here. Not 33 volts. You can name it something different, something that makes more sense to you as well. Like sometimes they'll write like 3V3 and V is kind of like the decimal, so 3.3 volts. Or I think you can actually add a period in here if you wanted. Yeah, you can actually add a period in here for 3.3 volts if you wanted. Mhm. Do you have all the connections for the ESP32? Okay. Oh no. Yeah, now you know. If you want the local net label, you can just click L as well. Yeah. So if I go to like a blank space, I can click L, I can give it a name, and then click enter, and it'll let me place it. Yes, I think looks like a hierarchical. Mhm. Correct. Yep. So I designed a 8-bit computer. Well, I didn't design it, but I put together one, and I converted it all over to the PCB. And of course, I needed more hierarchical sheets, so I actually used it, and I showed them like what it looked like, but I didn't use it, or I didn't have them make it. So I showed like bus lines too. You can actually do bus lines as well to simplify the connections. But it was a little wonky. It was weird with some of the connections. It it made all the proper connections, but it had errors for like some of them supposedly not being connected. And as many times as I deleted it or redid the trace, it would always say a certain select few had no connection.
Um,
Um, that would be from the linear regulator. Yep. So there's the 5 volts from the USB and then 3.3 for everything else. Yeah, so probably the power flag should probably be over here, but since they're connected to the same place, it made the error go away. So technically,
Yeah.
this is 3.3 right here.
No, I mean.
Oh yeah. Um, yeah, that's weird. Well, actually, right now nothing is connected to it. Um, here's the book I referenced. Right here. Yeah, so this must be a mistake, but there's not even a voltage here. So that's why I missed that.
Then, yeah. Okay, the power.
What do you mean?
Like, so you have a power flag here and then down on your regulator, so it's 5 volt.
It, yeah, so the power flags aren't like directly connected to each other physically. It's just so KiCad knows like where power is coming from.
Okay.
So this is being powered through the USB here.
So power.
Yeah, you technically don't need them at all, but you'll.
It's only.
Mm-hmm. Mm-hmm. So there's one more connection here. It's the VDE33 or 3.3 volt, and that's the power to the chip. What part do you need me to zoom in on? Just take a picture, yeah. Right. And then here's the connectors too. Again, you could probably rearrange the order. It's completely up to you of how to make all these connections, but this is how the actual developer kit had it laid out. And then you'll just have to make sure you put the proper silk screen to each connection. So the next main part right over here. So there's the USB connection here. There's a couple of TVS diodes here just for protection from ESD. So that I'm assuming it's so that if you're handling the dev kit so you don't burn out or ruin anything from touching on the board. And another protective diode here. Here's the whole thing. So this is for all of your communication with the ESP32. When you hook up the USB to your computer and you have whatever program you've made for the ESP32, this is how you would program the ESP32. Another thing is this board's going to be a 4-layer board. So supply is going to be a little bit more limited. I'll see how much we can order from our budget, but it's about $135, I think, for 5, which still isn't too bad, with all the components on it. So yeah. You probably really could have made this a 2-layer board too.
You know,
Yeah.
the big game.
Yep. Yeah. Or worse. Triple, quadruple. I watched a lot of videos and I've seen as much as like 8 or 10 layers. It's just crazy. Like how would you do the blind vias on that? Yeah.
Well,
Yeah.
multi-layer boards.
Right, right. Hmm. Data sheets? Yeah. I dealt with my fair share of that last semester.
It's a whole class. It's like that exposed to
Right. Yeah. It was something really new when I started uh, senior design. But I mean,
But that's
it's
what
good.
seniors do.
Yeah. For the text here, you'll just click on the add text here on the right, and then you can format it how you want. I had to do all the spacing manually. So actually, I just did tabs between each of them. So you can do that however you want. If you want them perfectly aligned, you can do spaces, it's fine. It doesn't really matter. It's just for anybody looking at the schematic to help them. Did you guys all get a picture of this?
Yeah.
Okay, so the last two sections are right here. So you can go ahead and take a picture of that too if you'd like. So once you guys finish the schematic, I just want to mess around a little bit with the auto router to show you guys what you can do with that. Again, I really do not recommend using an auto router to route your whole board. It can be really, really bad, and most times your board might not even work. More times than you'd like. I even watched, I was watching a video today about Altium's auto router, and it's just as bad, even though it's an industry standard software used for PCB design. Mhm.
I always thought around it.
Yeah,
And then you look, and
yeah.
And then you start scrutinizing it, and you're like, this, you're wrong.
Yep.
That's not gonna work.
Yep.
That's not gonna work. And
Yeah. I like using it just to get an idea of where like tracks are gonna go, and then as well as so, and then sometimes they'll tell you if it's even possible. Although even when the auto router can't do it, it's still possible sometimes. It just the algorithm couldn't figure out how to do it. So it's a I was thinking about doing the same thing. Maybe making a little knick-knack too. Buy a triple E logo. Copyright. So what size was the package for the chip? So did you find it? Yeah. Okay. Don't you have a exam? Okay. Yeah, yeah. Just wanted to make sure. What's up?
What's it called? Oh, okay. Yeah. Oh, no. That's crazy. Yeah. I actually like that.
Yeah, I think so. Yeah. Um, so we're approaching the 3 p.m. deadline, so we got about 3 minutes.
Oh, okay.
Would you guys be able to finish the schematic on your own time?
Yeah, definitely.
Okay.
Yeah, always.
So if you guys just finish that up, most of the components should have footprints, and this list is a little long to try and squeeze in. So I'll go over the footprints with you guys next Wednesday. Well, you'll have to take like multiple because there's a actually these drop downs have the same. Should be the same. Yeah, you can go ahead and take a picture of this if you want. And then oh yeah. There you go. Yep. 0603 is this size. Metric. It's really small. I have some 0402s on my senior design too. And Anthony knows the trouble of soldering onto those. All right, so you'll have to select the footprints. They're all right there under the footprint symbol. And don't forget to associate all your components. This will put the numbering next to all the components you've placed. That's this one right here. You just click that, click on annotate, and it'll add the numbers for all your components. And that'll be so you can reference it in the layout. So then next week, we're basically I'm gonna make the outline of the board for you guys. And then I'm actually gonna have you guys do slightly different dimensions so that it's symmetrical on the breadboard because mine is not symmetrical and it's bothering me. But we'll make sure we have proper dimensions, and then we're gonna arrange all the components, which shouldn't take too long. And then we're just gonna mess around with the auto router. I'm gonna show you what it's capable of doing, why it's bad, why it's good, and just different applications for it. And then I think after that, I might dig in a little bit to the KiCad calculator tools because I think there's a lot of really useful stuff in here that I've been finding that it just might help you depending on the design you have to do or whatever you're working on. It just might be something that's convenient to have. It's not going to be like life changing or anything, but it can help you. Right, right. So, and then again, maybe I'll show you guys how to properly install the JLC PCB plugin. You guys might use a different manufacturer, I don't know. But I'll show you guys how to add extra plugins and stuff. I'll do that next week. So I think that's everything I want to talk about. So I think I'll conclude this PCB session. I'll upload this now. The 5th episode should be on YouTube. You should be able to view that. If any of you guys have to review, I completely forgot to upload it, so that's up there now, and I'll upload this now. So thank you guys for watching. I look forward to seeing you guys for the next 2 weeks and wrap up this whole workshop. So hope you guys got something out of it. I'm gonna stop the recording now.